YouTube viewers. In this particular video, what we're going to do is we're going to predict equipment failures and maintenance needs through time series of sensor data. And we're going to do that using the ARIMA model. And that's auto regression and differencing and moving averages. And we're going to do that by writing a program in Python. But in order to write this program in Python, we've got to import some libraries that we're going to need to use to help us to execute the program when we run it. So the first library that we're going to import is math, which is an inbuilt, it's an inbuilt module. Let me just check something. It's not math, it's math. So I'm surprised that my program ran. It's because I didn't type in the right word. It's not math, it's math. So we're going to import math, which is an inbuilt library with Python. And then we're going to import NumPy as NP, which is a numerical library that also produces NumPy arrays. Then we're going to import pandas as PD, which is a data processing library that also creates data frames and series. And we're going to import matplotlib.pyplot as PLT, which is a visualization library. And then from statsmodels.tsa.arima.model, we're going to import ARIMA. So statsmodels is Python's statistical library. TSA is time series analysis, and that's a specific module in statsmodel. And ARIMA model is another module within time series analysis. And ARIMA is the actual function that we're going to use. So after we have imported the libraries, what we're going to do is we're going to simulate synthetic data. And the first thing we're going to do in that regard is we're going to set the seed. And then when you set the seed, what happens is every time you run the program, it will initialize to the same values. And then so you set the seed by typing np.random.seed, and you can put any number you want inside the brackets. And days equals pd.daterange, bracket start equals 2023-01, comma, periods equals 365, comma, frequency equals D. And then we're going to simulate Celsius temperature readings. So temperature trend equals np.linespace, brackets 30, comma, 80, comma, Lin days. So that's going to be 365. So that's a gradual increase in temperature. And then the temperature noise equals np.random.normal. And normal is a normal distribution, bracket 0, comma, 5, comma, Lin days. And so the mean is 0, the standard deviation is 5, and the sample size is 365. So that's going to give you random fluctuations. And the temperature data equals temperature trend plus temperature noise. So we're going to simulate the vibration levels. There are in arbitrary units. So vibration trend equals np.linespace, brackets 1, comma, 5, comma, Lin days. So Lin days is 365. So that's a gradual increase in vibration. And vibration noise equals np.random.normal, and normal is a normal distribution, bracket 0, comma 0.5, comma then days. So that's 0 mean, 0.5 standard deviation, and a length of 300 and a sample size of 365, and that's going to give you random fluctuations. So you're going to get your vibration data equals vibration trend plus vibration noise. So now we've set up the temperature data and the vibration data. So now we're going to combine the data into a data frame using pandas. So sensor data equals pd.dataframe, brackets, curly brackets, date, colon, days, comma, temperature, colon, temperature data, comma, vibration, colon, vibration data, squiggly brackets, and then brackets. So that means date is column 1, temperature is column 2, and vibration is column 3. But what we're going to do is we're going to set the date up as the index. So sensor data dot set index brackets date, comma, in place equals true. So that means the date is the index and the temperature is column 1 or column 0, and vibration is column 2 or column 1, because in Python 0 is your first number. So now what we're going to do is we're going to detect any anomalies. So anomalies equal sensor data, square brackets, sensor data, square brackets, temperature is greater than 70, and then, or sensor data, square brackets, vibration is greater than 4.5. So we're going to fit the ARIMA model to the forecast temperature. Train data equals sensor data, square brackets, temperature, square brackets, colon, 300. So you're going to use the first 300 days for training purposes. And test data equals sensor data, square brackets, temperature, square brackets, 300, colon. And you're going to lose the last 65 days for testing. So now what you're going to do is you're going to calculate the PDQ. So I've got it sectioned off. I've got it hashed off to turn it into remarks, because before I did this video, I calculated the PDQ, and it takes a while to calculate it. That's why I can't calculate it on the video, because it takes such a long time. And then so another problem that you're going to have is this calculate the PDQ may be okay on one program, but you put it in another program and not much has changed at all, but it doesn't work. And that's what I found to be the case this time. And then I had to correct the problem by, one, make sure that I imported the math inbuilt module, and 2, I had to set a frequency up for D. And then because for some reason it didn't work when I set the frequency up, when I didn't set the frequency up for D. So that's another problem you're going to have. So when you calculate the PDQ, it may work okay on one program, but you put the code into another program and it won't work, and then you'll have to troubleshoot it and try to find out where the problem is, which is what I did before making this video. So, but what I've done is I've talked long enough and I've left the code on the screen long enough to where you can pause the program, pause the video, and write the code down if you want to. So now what we're going to do is we're going to define our model. Model equals ARIMA, brackets, train data, comma, order equals 5, 2, 7, comma, frequency equals D. So your ARIMA, your P is 5, your D is 2, and your Q is 7. And model fit equals model.fit brackets. So now we're going to forecast the temperature for the test period. So forecast equals model fit dot forecast. Steps equals len test data. So that's going to be 65 because that's the last 65 days of the year. Forecast index equals test data index. So now what we're going to do is we're going to plot the sensor data. So temperature plot is plt.subplot brackets 2, 1, 1, plt.plot bracket sensor data dot index, sensor data square brackets temperature, label equals temperature Celsius, color equals red. And then we're going to make a scatter plot. plt.scatter brackets anomalies dot index, anomalies square brackets temperature, color equals orange, label equals anomalies. plt.plot brackets forecast index, forecast, label equals forecasted temperature, color equals purple, line style equals dash. And then we're going to make a vertical line in the graph, plt.ax speed line, brackets x equals train data dot index, square brackets -1, color equals gray, line style equals dash, label equals train test split. And then the title is temperature sensor data and forecast. The Y label is temperature in degrees Celsius, and you get a legend, and you get a true, and you get a grid. So basically, now what we're going to do is we're going to plot the vibration. So plt.subplot brackets 2, 1, 2, plt.plot brackets sensor data dot index, sensor data square brackets vibration, label equals vibration levels, color equals blue, plt.scatter, so we're going to have another scatter plot, brackets anomalies dot index, anomalies square bracket vibration, color equals orange, label equals anomalies. plt.title brackets vibration sensor data, plt.x label is brackets date, Y label is vibration AU, and you get a legend, and then you get a grid, and we're going to plot a type layout, and then we're going to show the graphs. So now we've got two graphs. The first graph is temperature data, sensor, and forecast. So you've got the temperature is in red, the anomalies are in orange, the forecasted temperature, it looks like it's in purple. It looks purple to me. And then train test split is in gray. So you can see that the first 300 days is your training data, and then the remaining 65 days is what you're going to actually forecast on. And if you look at the forecasted temperature, you can see that it's making a slow increase. So now we check the vibration sensor data. So you've got your vibration levels in blue, and you've got your anomalies in orange. So that concludes this video. The next video we'll be talking about another statistical subject. So I hope that you decide to watch the video and learn some more about time series forecasting.